Hello class. Today I'm going to be talking about section 11.3. We're going to look at how to find the area of a sector and how to measure arc length. So you can get the rest of your vocab from your book or from Google Classroom. I have these filled out for you. But I'm going to go ahead and just start with the formulas for now. So our arc length is a portion of the circumference. So circumference of a circle is 2 pi r, right? Well, to get the arc length, we'll actually use an L for length here. We're going to take that 2 pi r and we're going to multiply by the portion of the circle. So we find the portion of the circle by taking an angle, and we're always going to use the central angle. So whatever the central angle is, we'll call that m degrees. It's always going to be out of 360 within a circle. So we're going to multiply that portion, that part of 360, whatever that angle is, times the circumference to give us just the length of that part of the circumference. The sector area formula is very similar. We take the area of a circle, but we don't want the entire area, we only want a portion. And we're going to get that portion again from that central angle out of the total, 360. So that portion we multiply by the area to only get the part that we're looking at. So we're going to use both these formulas in these next examples to help us find length and area. So example 1 wants me to find the arc length of BC. So here's how you would write this proper notation. We're used to seeing M for measure, BC, and then we're actually going to draw a little arc over it. So that's the proper notation for saying the measure of an arc. The measure of arc BC equals, so we're going to use our arc length formula here. So we've got 2 pi r. I'm going to go ahead and plug in the radius. I'm told here the radius is 3, so 2 pi times 3 times, now here's where we put our portion of the circle. So here's my central angle, 80 degrees. I want to do this portion out of the entire thing. So that's going to be 80 over 360. And then this is just a matter of plug and chug. So I like to leave my answer in terms of pi, typically if we can. So I'm going to go ahead and say that 6 pi times 80, over 360. Well, my zeros can cancel there. I've got 8 over 36, and I can always simplify diagonally. 6 goes into 36 6 times. So right now I've got 8 pi over 6, which I could reduce that to 4 pi over 3. So it's 4 pi over 3, and then my unit is inches. And then, of course, you could turn it into a decimal if you wanted by multiplying 4 times pi and then dividing by 3. So the measure, I guess I'll write that out complete. The measure of arc, BC, proper notation, is equal to 4 pi over 3 inches. There would be my final answer. Okay, all right, we're going to do the same exact thing here, but we're going to do the area. So I'm going to use the area formula, where I'm taking the area is pi r squared. My r here is 10, so I'm going to plug that in. Pi times 10 squared, now times the portion of the circle. So this is the sector I'm trying to find here. So 95 degrees out of my 360 is that portion. So we're going to multiply by 95 over 360. All right, so again, I can go ahead and follow my order of operations. So I've got 100 pi times 95 over 360. All right, and let's see, if I multiply these, I guess I could cancel out a 0 here. So multiply 10 times 95, I get 950 over 36 pi. And this one's not a very nice fraction. We can certainly leave it like that in terms of pi, but I'm going to go ahead and turn this one to a decimal. So 950 times pi, use your pi button on your calculator, and then divided by 36, and we do get that is approximately 82.86, and this is an area, so remember we're going to have square units. So square feet for this particular thing. Okay, so that is how we use the formula to find the area of a sector. Okay, number 3, I don't think this is too difficult of a question, but it's important for us to think about. What is the difference between arc length and arc measure? So these are ones that you guys have defined earlier on in the page from your book or using my notes on Google Classroom, but the arc length is actually measuring the linear distance. So arc length is linear distance. In other words, if we took that arc, for example, if we look at this BC, and I were to straighten it out to form a line, how long is that? I could measure it with a ruler, for instance. So I'm looking at linear distance. Arc measure is talking about the angle. So we can say it's an angle measured in degrees. So for example, again, if I'm looking at this arc, the arc measure is 80 degrees. It's the same as that central angle. So the arc length is what we found using the formula. The arc measure is that angle in degrees. Okay? And I think we kind of talked about this already, but where did we get those formulas? Well, we are already using formulas we know, circumference and area, but we're only taking a portion. So that's why we multiply by whatever our central angle is out of 360. And that's where we get both those formulas from. All right, class, if you need more notes, please refer to Google Classroom, and thanks for watching.